Hello and welcome back to the lab. Today on the bench is another 8904A. So this is going to be Unit 2. We currently have an Option 4 unit. We're going to be de-Option 4ing it and moving it to an Option 1 and 2. This does come with Option 1 and 2 already, and it is of the appropriate serial number for all the fancy goodness. If you have any questions about all of that, check out the previous 8904 video, and we go into that in a little more detail, as well as rebuilding the power supply. We're going to gloss over rebuilding the power supply in this one, although there is a couple of things we're going to hit, because there was a couple of things I left out of video 1 that we're also going to address. There will probably be one more of these that hits the channel, because I'm actually looking for an Option 6 unit, which will be only a 2 input, but then it's a Option 6 converts it from a 50 ohm output to a 600 ohm output through a transformer and a high voltage output as opposed to a power output, which we have on this particular unit. We're also going to take a look at, maybe in this video, maybe not in this video, we'll have to see how shipping goes, but we're going to take a look at replacing this EL screen that's in this unit. The electroluminescent screen on these 8904As is awful to read. It's really bad. Fortunately, it's rather easy to replace, but there is some things that we'll have to do to get ready for that. We'll have to remove some parts off the board, get a screen, get a couple in, because I'm going to do the other unit that I have, and we'll go from there. In the end, hopefully, we'll have 3 of these units that work, all with much better displays that are nicer to look at, and do some cool stuff in the lab. So, with that, let's get into it and get this thing ready to go. When lifting the covers, we found... Uh-oh. Something exploded. That went pop in a lab somewhere. So let's see if we can't figure out what that was. Should be able to see a replaced component in there to begin with. Okay, if we take a look at the bottom side of the unit, we can see there's plenty of cable to move the connectors back up front, and on my other unit all this cable is just coiled up here. So the cabling for the rear input and the front input are actually the same cable. I'd be shocked if this wasn't the same part number. So very easy to take a Option 4 unit and turn it into a non-Option 4 unit, and vice versa. If you want the rear inputs, you just move the BNCs to the back, move them to the front, and reuse the plugs on whichever side you don't want to use. So that's quite easy. As discussed in the other unit, we have a battery. We'll check the health of this battery and see how long it's got to go. This battery backs up some RAM that's on this board, and that RAM stores the options, and it also stores the serial number of the device. There is a procedure that if this battery goes completely flat, to bring the unit back to functioning. I am looking for that procedure right now. I want to have it just in case. And but we'll check the voltage in those batteries. The reason I want the procedure is because if I ever have to realign one of these or do that, I'll have what we need and we'll be good to go. It is not hard. The hardest part about that procedure is re-injecting the serial number into the RAM. The software options are not a problem to get those restored. One thing to note with the, as I've said, software options, Option 1 and Option 2 are hardware options. They're not software options. So when you have an Option 1 or Option 2 unit, you get a second board at the bottom. There's actually a sandwich here for the function generators. So if you don't have Option 1 or Option 2, you'll only have one board down here. You won't have 2. Option 3, 3, and 5 are software options. Option 6 is a transformer block that is actually mutually exclusive. You cannot get an Option 1 or 2 unit with an Option 6 unit, as far as I'm aware. But it's the transformer that actually does the front panel, or that does the outputs. Where are we at? Oh, yeah. Power supply. As per usual, we will get this replaced, and we'll get all the caps redone on here, and get this ready to go for the long haul. I believe this is the capacitor that may have exploded. That is, well, it says CR. That wouldn't be it. Actually, that says R28. Oh, yeah, 330K ohm. That's a resistor. Huh, that'd be an interesting part to pop. We'll have to see what my other unit's power supply looks like. One of the things that I did not do in the other video that I probably should do, and this board doesn't look like it has any of them, is there's reefa caps. They are notorious for going bad, and yes, I should replace those with proper XY rated components. So these might have already been done because these are blue. And this one might be one too. That's a Eero, not a reefa. So these are probably going to be okay on this supply. I'll have to check the other one for those capacitors because I'm pretty sure it was on there. A couple of people in the comment section mentioned that I did not replace them. Yes, I should. I did not have any appropriately rated ones in stock, and I am in a 120 volt country. Realistically, I could get away with leaving them in. I'm not going to for longevity's sake, but in a 120 volt country, they tend not to go bad. If it was a customer unit, of course they would get replaced. It was a personal unit for the lab, so if they go out, I'll just crack it open real fast, swap them out, and it won't be a big deal. But anything that's leaving the bench for other people that don't have quick access to me, most definitely they would get replaced if that was requested and desired. The failure mode on those is the plastic cracks moisture ingress into the paper that they're made out of, and they just short out and burn up. One of the other things that likes to crap out on these is these input filters. Schaefer had a bad batch of these at some point that are not aging well, and I know a lot of guys, if they're the Schaefer noise filter, they're replacing them on site, especially in the 240 volt countries. Because when they go, apparently they smell horrific. I've never had one die on me, but I'm in a 110 volt area of the world. So there we go. The display that would be replaced is up here. This is the EL panel. Serial connection to the EL panel. And this guy right here. I think U50 is what you need to pull out. U50 is the inverter for the 80 volts AC to drive the electroluminescent backlight. And if you unload the inverter, it can go crazy and burn itself up. So if you're going to do a screen modification on these, might be a good idea to pull this out. I'm going to confirm that and triple check that part. We will get deeper into that when we do the display replacement video. Yes, there will be a display replacement video on this particular unit. Okay, let's talk about the outputs on this particular unit for a moment. I initially thought that the outputs with low and high, so this would be channel 1 high, channel 1 low, that was going to allow for differential signaling. That is not the case. So we actually have two outputs that we can send waveforms to. We have channel 1 and channel 2. The high and low are less differential output, more source measure unit style outputs where we have force high and force low for true floating operations. So when we turn the floating on, our return channel is actually through the low port as opposed to the barrel shield, so we can have high output, low return, and shielded on both high and low sides of the signal. So that is why the 4 B and C jacks are present in the function generator. So not for differential, although with option 5 you can sync two of them together and you can get differential. And you can do one channel of differential using outputs 1 and 2, because you could sync the 2 and then phase invert 2, and there's your differential signaling for push-pull. But you can't get 2 channels of differential signaling. You can only get 1 with this particular configuration, the way this was engineered. That's not necessarily a problem, just a limitation of the device. Okay, we got most of the capacitors replaced. This 2200 and this 2200 are still in position due to the fact that I don't have any 2200 microfarad capacitors, so that will be a quick order to the usual suspects. All the rest of them are finished up. Long life Rubicons. We're going to get these two swapped out when I get those in from the order as well. These typically don't have a problem. The bulk caps on the pre-switching side, so this would be what's storing the current that is switched by this transformer from the AC line. So the AC line comes in from the switch, gets rectified, and stored here. Being in a 110 volt country, these did not see a lot of stress. In a 240 volt country, they will be stressed almost twice as much. Well within their ratings, though. They are 200 volt, 270 microfarad. We will bump them up, and that won't be a problem. This capacitor I wanted to be careful of because it is right next to this power resistor, so definitely wanted to swap this one out, and I made sure to bias the power resistor that way and the capacitor that way to keep from heating this up and roasting it. Everything else was pretty straightforward. The conformal coating on the bottom of this power supply still sucks, and especially with some of these high current traces, as we can see running around in here, this board took a lot of heat to get these parts out and in. I did dial up the desolder tool and the soldering iron to 750 Fahrenheit. That is way higher than I usually work with. With those irons, I usually work at the 650 range because they have the power delivery. I don't need to turn them up to get the components to go do what I need them to do. I did have to clean the soldering iron, the desolder tool, more often when working on this board because this conformal coating just wanted to clog things up and come in. The 750 degrees did burn through it without too much trouble, but I did do it under filtration. So I'm not sure what exactly that conformal coating is, but I did not want to breathe what comes out when it gets hot. So we did use it we did do all the work under the fume extractor, which has good filters under the bench. I think that's it for right now. We're going to throw this back in, do a burn-in test, order these up, order these 2200 microfarads up, and continue from there. In testing our RAM battery, we are at a very healthy 3.3 volts, so nothing to worry about there yet. Okay, you guys can experience the first power up with me together. So if I did anything wrong, we'll get magic smoke. We'll see what happens. We are drawing about 50 watts, and it does look like we have booted up. The EL display is as bad as it always is, because the funny thing is, the backlight's on. Like, this display gets even darker when the backlight turns off. And we want to amplitude 1 volt, 1 kilohertz waveform. And we do have a waveform on the scope. Not a bad 1 kilohertz waveform. Everything looks good. So we're just going to let this burn in for a little while and see how it goes from there. All right, we're going to let this cook for a while. I put the cover back on just loosely. It's not even screwed down yet, just so the lab cat doesn't sniff around the 400 volts in the power supply. And we'll let it get nice and warm. Well, the DigiKey order came in, so out with the old and in with the new. And the 2200 microfarad capacitors fit just barely, but they do fit, and everything is good and clearanced correctly, so nothing to worry about there. We're going to go ahead and fire this up, let it do some more burn-in, and see how it goes. Okay, coax lines are hooked up to the scope, and if I did my job right, we should not have any excitement. Or booting up, so that's a good thing. Channel config. Amplitude 1 volt. And amplitude 1 volt. And we want phase 180 degrees. Perfect. And our 2 sine wave outputs, we're triggering off of channel 1, so channel 3 is 180 degrees out of phase. And we will just let this, put the cover on it so the lab cat doesn't lick the 240. And we'll be back in a while. Well, I was cleaning a little bit of the staining that happened on the bottom lid, and I ran into something interesting, so we figured I'd turn the camera on. Doing a short bit of failure analysis, what we have here is we actually have some stuff that is embedded into the chassis right here, a little bit of metal balls, things like that. Also, given where this position is, we can determine that most likely this is the capacitor that blew up. And when this one went, it went with quite a bit of authority. To embed some metal into the chassis, which we'll get this off, but as you can see as we wipe off the smoke staining, we still have a bit of metal parts that'll catch a screwdriver. So there's when that went with some authority. But that's clean enough for the lab. So there is a couple of options that run around with these units, and one of them is option 5 that I was kind of interested in, but I'm not sure option 5 is going to work for me in the lab, because option 5 on this unit gives you phase coherence between the channels, and you can daisy chain up to 8 units to get 16 or 32, depending on the options, phase coherent outputs at the front panel. The problem with that is it uses these sync in and sync out connectors, at least from what I've been able to determine from the online literature. I'm still looking. Those would obviously traverse to the back panel somewhere and to daisy chain the equipment together. I think I'm going to need to find 2 sets, so 4 total, of the sync in, sync out, and to get them on the back panel to use this in the configuration that I was hoping for. The other thing to note with that is when you're going to do the phase coherence, because it's phasing, all the cables have to be the same length. So the cables have to be the same impedance, they have to be the same length, because the signals need to arrive as matched in time as possible. So getting that working there's a lot more nuance to that than at first glance. So something we'll definitely be looking into the future and going from there. There's also not a lot of information on option 5 on these units, so I'm going to do some more digging there and figure out what we can and can't do. This unit has survived all the burn-in testing and everything that I've wanted to do to it, so this unit is complete. I am ready to get this into the lab and get it into service. We are going to hook this up to the rubidium as well as the other one, so we'll have 4 outputs instead of 8. 4 very nice DC to 600 kilohertz adjustable outputs, and that we can also set floating, which is one of the reasons why I wanted this particular unit. In a future video, we are going to address the displays in both of my units. I do need to order some parts in, get some things in, and figure some things out before we put stuff in front of the camera. If there's anything else you'd like me to talk about, see, or do anything with these units, let me know, and we'll see what we can make happen and get put in front of the camera. So let me get the covers back on, and then we'll wrap this one up. All right, thanks for stopping by the lab and taking a look at the 8904A Unit 2. There will probably be a Unit 3 because I'm also looking for an option 6 of this unit. If you liked the videos and found everything informative, hang around, hit the subscribe button, the bell, and all the YouTube algorithm things. And if you'd like some more content, check out the Patreon page. Patreons are running about 5 videos ahead. All the videos will eventually come up to YouTube. There's nothing behind the paywall. If you'd like some more content as soon as it's finished being edited, check out Patreon and we'll run from there. As always, I am in the comment section in between videos, and I love talking to everybody and growing with the channel. So I will see everybody in the comments section, and more is always on the way.